Now let's see complementing Boolean expressions using De Morgan's law. Right. So you have a Boolean expression like a plus b and you want a complement. So for that De Morgan law can be used. So for that, let me tell you one thing. You can apply De Morgan law when you have a situation like this. A plus b bar. This can be same as so this alpha can be equal to anything. Alpha bar plus beta bar. So if you have a bar plus b whole bar, then what will it become? क्या बन जाएगा ये कुछ भी हो सकता है, राइट? तो ये a b बार हो जाएगा. तो ये तो बहुत आसान है. अब अगर आगे बात करें तो a b बार, तो ये एंड जो है यहाँ पे ये एंड और बन जाएगा, राइट? ए जो है वो ए कॉम्प्लीमेंट बन रहा है, बी जो है वो बी कॉम्प्लीमेंट बन रहा है. ये पूरा आइडिया है, राइट? So the literals are complemented so if a bar dot b whole bar, then what will become? And will become or b will become b bar and this a bar will become a. So we'll get a plus b bar. So this is very simple. So note this thing. If you want to use De Morgan law, then your expression should have only these things: literals and or not operations. You know what is a literal? A comma a bar, right? Variable comma variable complement. And or not operation, no other operation, right? XOR XNOR not those operations. Then only you can use De Morgan laws to find the expression for complement of a function. Now what we do is that, for example, here you can notice the same idea. What will happen? For example, if I have a bar plus b, this is your f, a comma b. Then what we have? For a moment, a bar, we have b and or. We have these three things. So these three things in this expression. Now what will be the complement of this? E complement. A bar plus b. You have to find this. It will become like this. Or will become and. B will become b bar. A bar will become a. So this is the entire idea. You will get a b bar, right? Which is a b bar. So if your expression and that expression contains variables a comma b, a bar b bar, and or, if you have these things, no other things, then how to find the complement? How? Very simple. A will become a bar, B will become B bar, A bar will become A, B bar will become B, and will become or will become and literals will be complement. In simplest form, if you want to say, if you have a literal L plus or E bar, right? So over here L bar, comma, over here and will become or. So now let's do the practice. Replace, let me just write it down. So and with or with and, 1 with 0, 0 with 1, x with x bar, and x bar with x. So this is something that you have to keep in mind. So here you can just kind of update it. 0 and 1 will also be there. One and 0. So now you can have an example over here. X y bar. So you can have x bar plus y bar. So this is x plus y bar equals to x bar dot y bar. So a plus b bar and c bar. So this is basically over here. This and will become or, and inside over here it will become a bar, and this b bar will become b, like this, right? So which is actually a bar b plus c. Now there is another one over here, which is a plus b bar c bar b bar is equal to what? So there is this complement over here. So there is one thing to notice, that only complement, right? Don't make this mistake. There should be a complement, right? So for this expression you have to find the complement, and will become or, c bar will become c, b bar will become b, this and will become or, and similarly a bar and will become or will become and this b again. So this is how the answer will be there, right? Now one more question. So the complement that will be very simple. Answer will be a b bar c whole bar a c d and this will be the answer. Is this your answer? This is very simple. Try to understand. For example, if you have a b bar plus c whole bar, so what it will become? Just apply De Morgan. Don't do any kind of simplification. This is your alpha. Think of it as alpha. So it will be like ab bar complement dot c bar. This is same as ab c bar. As simple as that. For example, a plus b bar multiplied by c bar whole complement, that will be a plus b plus c. They are same expression. Now this expression over here is same as this expression. If you make this, sorry, the sound was not working. So this expression is same as this expression. If you make the truth table of this expression, then the truth table of this expression will be same. See, a plus b bar c bar whole complement will be, think whole of this as alpha, right, x, and think this is y, and this is xy. This is x, this is y. So here it will be a plus b plus c. So here the double complement is working. So a complement whole complement is a, right? So the answer will be like this. So if you apply De Morgan, this is what you'll get. So you'll get a b bar c, and you'll get a c d, right? And b bar plus c. Now you can further simplify. From where we are talking about this? About this one, where f equals to a b bar c whole bar plus a c d bar plus b c bar, and then this whole bar. So this is how you can get from here. Now from all the properties we have, we can say that this a and a will become a, and this c and this c become c. Then you'll have b bar and d, and then multiplied by b bar plus c. Now you can apply the distributive property. This multiplied by this, a c b bar d b bar plus a c b bar dc. Right? Now we can create a c b bar d plus a c b bar d. This will be a c b bar d. Right? So this will be the answer. Now we know AA equals to A, CC equals to C, AB plus C equals to AB plus AC. Right. So now tell me what is the complement of this one. AB bar plus A bar B. This is your actually XOR, so complement will be XNOR. A bar B plus A B bar. A bar B plus A B bar. So now this whole complement will be A B bar. This whole complement will become A plus B bar, and this whole will become A bar plus B. Okay. Now this is your exclusive OR. So what should be your complement? Exclusive NOR. So this is your equation for exclusive NOR. So X complement will be exclusive NOR. Now what is the complement of this function? This is your function, and for this complement will be OR will become AND. This complement will become Z. Okay. And this AND will again become OR. This Y will become Y bar. And the complement of this inside it will be X bar multiplied by, that will be V plus W bar. Right? Another bracket will be there. You can check the answer. Now look at this one over here. This is A plus BC. So जब आप इसको expand करोगे, when you will try to solve it, तो इस तरह से नहीं करेंगे, इस तरह से करेंगे A plus BC in this way. Many people will use this thing, but you'll always remember the precedence. Parenthesis will be solved first, and then comes this thing. Now the next topic is dual of Boolean function. So what is dual nature or the dual of Boolean functions? Before that, we'll use to understand some of the more useful properties, of which the first one is the absorption law. So absorption law is something like that. If we have expression like this, A plus AB, and in which there is this hidden 1, because A dot 1 is A only, and what will the value of this will be? If we try to solve it, then we get A 1 plus B, which is actually we are taking A common on the from here and here between the or sign, A 1 plus B, and then we get A over here, and 1 plus B, anything 1 plus B is 1 only, and we get A only. Similarly, for the other one over here, we multiply it with double A plus B, and A into A is nothing but A, and then A plus B, and then absorption law we get A. So this is how we solve it. Now let's move further. Alpha plus alpha beta equals to alpha. This is our absorption property. So this is something which we'll use many times. So this alpha will absorb this alpha beta. right? Now the second one is, it doesn't have any name, but again it is very important. It doesn't have any name, but it is again very important. Now what will it be? This is very different from absorption property. What it does is that absorption property is something like this: a plus ab. But here what will happen is that here this you'll remove. You get a plus b. And what is the proof? What is the best method to prove it? By case method again. So by proving it by case method, now here if you have anything plus its complement into beta, then you can remove its alpha complement and you can get alpha plus beta. This is your another property. So this is again the idea. So for example, again, if you have a plus a complement plus ab, you can again use it. What? You can remove it. You can get a complement plus b. Why? Because this is again the complement over here. You can remove it and a plus a complement plus b. Now a complement plus a complement b equals to a complement. This is your absorption law. Here it is a complement plus ab. This is a complement plus b. Right? So all of these things are very useful. You should directly remember them. Now one more property we have, that is called consensus. Consensus is something, consensus property. Right? So over here you have AB plus A bar C plus BC. So this you can remove this. How? You can write it down AB plus A bar C. This is the idea. You can call it Sansanasan property. The name doesn't matter, but you should check it. This property you should check. With A you have B, with A bar you have C, and they are together, and you can remove this thing. And you can get AB plus AC. The proof. With A you have B, with A bar you have C. It's like this. Then in the happy times of A you have B, in sad times of A you have C, and there they are together. Then finally you can remove them. We don't need you, right? In sad times B is not there, but C is there. Something like that. So you'll get AB plus A bar C. So by case proof, only two cases are possible again. A will be 0, A will be 1. If A equals to 0, then LHS will be, if A is 0, this will be 0. This will be C. RHS will also be C. You'll see they are same. A is 1, LHS will be B. A 1. Then it will also be B. Proved. So one thing you notice here, one thing very interesting, that what you have been told, that in happy times of A, B is there. In sad times of together, A, C is there. So you can remove B, C. Now here in the sad times of A, C is coming, both sides. And in the happy times of A, both side B is coming. So story is consistent over here. Basically they are redundant. This is your removal of redundancy. Removal redundancy. Right. So if you have A plus A, this is redundant. A plus A. You can write in directly A. If you have A plus A, you can remove it A plus AB. This is again absorption row. Again A. Same thing. AB plus A bar C. Here this BC is redundant. Then AB plus A bar C. Right? In this situation, who is redundant? This will be A plus C. Here A bar plus A bar C. Who is redundant? Absorption law. Here this will be redundant. A bar plus C. All of these things should be clear. Now let's see dual of a Boolean function. If you notice all of the properties, they all are coming in pair. Every property, whatever we learn, ML, identity, add important, complement, double negation, right? Commutative, not double negation, but commutative, right? De Morgan, absorption, redundancy, laws, right? What I'm trying to say, the Boolean algebra laws are given in pairs to show the algebra satisfy a duality. Whenever you study identity law, for example, then you have seen A plus 0 equals to A dot 1 equals to A. So they are dual of nature, dual of each other. So all of the properties that we have seen are in pairs. For example, distributive property, distributive law. It is also in pair. A dot B plus C equals to AB plus AC. A plus BC equals to A plus B, A plus C. Again they are in pairs. Yes or no? So these are also dual of each other. These two equations. Now let us find dual of a function. Dual of a function. One function you have, so you have to find dual of a function. Right? For example, if I give you a function a comma b, then what will be the dual? This is your function. Here also the same thing you will do, that you have done in De Morgan. So you can see, if Boolean expression only contains literals and or not operation, no other operation, then we can use find expression for dual function easily. Right? Only literals and or not operations, no any other operation. Okay? Now how to find this? If you have a function, for example a comma b, ab, then what will be its dual? Don't disturb the literals. This is the only condition, right? Variable literals, don't disturb them, right? Everything will be same as De Morgan law. Now remember, a will remain a, b will remain b, and will become or. So this a or b is the dual of ab. So for this ab, the dual will be a or b. So the only change will be ab, a bar, b bar plus. So don't disturb the literals. Everything else will be same. So if I give you this function a comma b, and this is a function a plus b, then you have to find the complement. Then how to find the dual? Don't disturb the literals, right? Just do this. Everything is same as this. So this is the entire idea. So to find dual, if you have a function, in that function a, b, a bar, b bar plus and 1 0, then how to find the dual, right? What you'll do, don't disturb the literals. These literals you don't have to disturb, and will become, this will become or, this will become 0, and this 0 will become 1, and all of this will be same, right? So this a will be a only, b will be b only, a bar b a bar only, b bar will be b bar only. Everything will be same like this for the literals. This is the only difference. Very simple. Let's understand with the question. Let's take a question. You have function f, a comma b, a comma bar, b bar, a plus b 0 1, right? So if you have f d, right, and you have f, so if you find complement, then a will become a bar, b will become b bar, a, right, b will become b, and plus 1 0, like this. All of these things will change. This was the complement thing. For dual, only these things will change. This will be b bar, this will be a bar, this will be b, this will be a. Don't disturb the literals, and here all of the things changes. Now let's take this question. Find f dual and f complement. Then what will be the answer? This or will become and. Inside you'll have b plus a bar. Very simple. This and will become or. This or will become and. This and will become or. This will become AB bar. This will become A bar plus C. Right? For complement, you have to change. Everything will be same. Just do the complement of literals. A bar, B, A plus C bar, B bar plus A. Right? Okay. So if you want to go from dual to function, if you already have, let's assume you have a function. If you already have a dual, this is your function A bar plus dot 0 1. This is your function. If you already have f complement or f dual, if you already have f complement like this, then how to find f dual? Just literals you have to change or complement, right? Everything else will be same. Just do this from f complement, right? For example, if I give you this question, f equals to a bar plus b c bar, then complement will be a b bar plus c. Then what will be the one? I don't need to start from here. I can directly take from him. This I'll make complement. This I'll take b. I can make complement, and that's it. Is this clear? Now tell me few things. Now on one side I'm writing function, I'm writing complement, I'm writing dual. Right? This is 0, this is 1, 1. Right? This is how it works. This is a function. This is 0, this is 1, 1. If this is 1, this will be 0 and 0. Right? This is how it works. Because remember, in dual and all of them, which is the 0. 0 is converted to 1 in both complement also and dual also. Only literal is not affected in dual. Right? Rest, both the things get changed. So if you have this, then for the complement, a bar, and it will be a. Don't disturb the literals in the dual. Right? If you have b, this will be b bar, but it will be b only. So for this function only, this will be like this. Now again, further, if function is a plus b, then what will be the f complement? A bar, b bar. F dual, that will be ab. If your function is ab, f complement will be a bar plus b bar. A plus b. Function is a plus 0. A bar into 0 bar. A into 1. Okay, this is clear. A bar into 1. A into 1. Sorry, over here it will be a bar into 1. So don't disturb the literals. This is the basic point. Basically, to find dual of a function, don't disturb the literals. Very simple. This is the only point. Now, can I say that for all functions, f is same for f dual? Are they same? The answer is clearly no. Consider this function ab d, a plus d. They are different. Now another question. Is it possible yes, it is possible. Not always, but it is possible. If f equals to a, then f dual is equals to a. It is possible, but not always. A plus b, then f dual is equals to ab. But here, this is different. Not always, but possible. Now, is it possible f is equal to f complement? Answer is no. This is not possible. This is definitely not possible. They can never be same. Another question. Is it possible for some f dual is equal to f complement? Yes, this is possible. There are many functions possible, but let us take some example for now. This type of functions for which dual and complement are same, those functions, for this take this a exclusive or. Find this complement. So this is your function. If you have to find f dual, then what you'll do? A b bar plus a bar b. F complement you already know. Ignore. Which is ab plus a bar b bar. What will be f dual? That will be a plus b bar a bar plus b. That is equal to, if you apply the distributive property. So a by a bar, a bar, a with b, b with a bar, b bar with b. So what you're getting? ab plus a bar b bar. So for this function, for f equals to f dual equals to f complement. It is always true. So remember this thing, that for function f is never equal to f complement, but f can be same as f dual, right? So in the next lecture we will understand simplification of Boolean function. So first of all, for now, just look at few things, which are ab plus a bar plus b. Can you simplify this thing? What you'll do? You'll take b common. A plus a bar b. You'll get b. So you can simplify. Right? This is again very simple. And this is nothing but 1. A plus a bar. Next, a plus ab. This is absorption law. You have already studied, right? This is a. If you have another equation will come in pairs, right? So if you have an equation like this, e equals to f, then what is the dual? That will be very simple. It will be e dual equals to f dual. If two things are same, then their dual will also be same. E comma f, then e equals to f, then e dual equals to f dual. So if this is equation and this is another equation 1 and equation 2, if two things are same, then their dual will also be same. It is not that e equals to ed. No. So again, the same thing goes for complement. If two things are same, then their complement are also same. So this is the equation that you know, a plus ab. This is your equation 1, right? So what will be the dual of this equation? A plus b equals to a. So one last thing, that after proving one theorem in a pair of theorems, the other theorem follows by the duality property of Boolean algebra. So you can create another theorem using duality property. For example, if you prove a b plus c equals to ab plus ac. If we prove this, then automatically then the dual will also be proven. If two things are same, then their dual will also be same. How? What is the dual? A plus bc. What is the dual of this? A plus b, a plus c. So if you prove this theorem, then automatically this theorem will be proven by the property of dual. So let us simplify one thing. F equals to x bar y z, x bar y z plus x z. Now let's see what you can do from this and this. Let's take z common. Okay, x bar y plus x z plus x bar y z bar x plus, you can remove this thing, you'll get x plus y z plus x bar y z bar, and you'll get again on solving xz plus yz plus x bar yz bar. Now what? Now from this and this you can take y common, right? Then this z bar is again redundant. See what you can do, y common, then finally we got xz plus yz plus x bar y. So in the happy time z is there, sad times y is there, sorry, yeah, y is there, and they're together. So what? Remove them. Xz plus x bar y. This is the consensus power property. So they were doing party, so we just removed them. So this is the answer. That's all for this lecture. We'll meet in the next lecture.